Hi, I'm Mr. Miller, and this is a lesson on solving trig equations using identities. In this lesson, we're going to look at 4 examples of how to solve trig equations using identities. The first example we're looking at has a double angle in it. So when you see sine 2x, that should be a cue to you to use a double angle identity. So here's a substitution you can make. It's 2 sine x cosine x. Once you get to this point, you should recognize that there is a common factor here of cosine x. So I'm going to factor that out. And at this point, we've got it in factored form. So we've got the first factor is cosine x, the second factor is 2 sine x minus 1. We can set each one of those factors equal to 0, and then solve. Notice that I've already done some work with the 2 sine x minus 1. So 2 possibilities, either the cosine x is equal to 0 or the 2 sine x minus 1 is equal to 0, which means that in that case sine x has to be a half. So now solving each one of these equations that results, here's what we get. So first of all, we know that cosine x is equal to 0 at pi over 2 and at 3 pi over 2, and that's solving on the interval that we want from 0 to 2 pi. On the other side of things, we've got sine x equals to a half, and so we know that that's true when x is equal to pi over 6 and 5 pi over 6. So those are the 2 roots on the interval that we're interested in, which is between 0 and 2 pi. Once you're done, if you like, you can put all of the roots in order. So I just put them in order from least to greatest. So the smallest root is pi over 6. The next one is pi over 2. The next one is 5 pi over 6. The next one is 3 pi over 2. And that completes the first example. Let's take a look at what's next. Next, we have sine squared x equals a half tan x cosine x. And we want to solve on the interval from 0 degrees to 360 degrees. So notice that normally we solve in radians. In this case, we're solving in degrees. Now, if we do a substitution on the right-hand side, replacing the tan x with sine over cosine, what you'll notice is that there is a common factor of cosine that can be divided out here. So I'm going to do some simplification first. Once I do that, I can easily take this term, the 1/2 sine x, and move it to the other side of the equation. So now I've got sine squared x minus a half sine x equals 0. From here, I'm going to take out a common factor of sine x. And so now I've got it into factored form. So once I've got it in factored form, either sine x equals 0 or sine x minus half equals 0. I'm going to solve each one of those situations. So of course, we know that sine x is equal to 0 when x is either 0 degrees or 180 degrees. And we know that sine x is equal to a half at pi over 6. Sorry, we're working in degree mode. 30 degrees and 150 degrees. So now if you want to put those in order, you can. And so we'd start with the least one, which is 0 degrees. Then we've got 30 degrees, 150 degrees, and 180 degrees. And these are all the solutions on 0 to 360 degrees. Next, we've got cosine 2x equals cosine x, and we want to solve for all x. So immediately when you see 2x here, you should be thinking, I'm going to use the double angle formula. So the double angle formula for cosine goes like this. 2 cosine squared x minus 1 equals cosine x. Now I know that there's 3 versions of that identity, but the reason that I chose this one in particular, the 2 cosine squared x minus 1, is because of the fact that it involves cosine. And of course on the right hand side of the equation we've got cosine, so we want to have everything in terms of cosine. Once I've got it like that, I can move all terms onto one side of the equation. So it'll look like this, subtracting cosine x for both sides. And from here, we can put it into factored form. So use whatever method that you need to, whether it's box method or decomposition. If you're not sure how to do the factoring component, make sure that you talk to me and I can certainly give you a hand with that. And once you have it in factored form, of course, you know that either 2 cosine x plus 1 is equal to 0 or cosine x minus 1 is equal to 0. So if I solve each one of those scenarios, we're going to have either cosine x is minus a half or cosine x equals 1. So we know that cosine x is equal to negative 1/2 at these two angles, 2 pi over 3 and 4 pi over 3. Of course, because it's saying to solve for all x, we also have to add multiples of 2 pi to get to all of the other roots, where, of course, that n is an integer. So now on this side, the cosine is equal to 1 at 0 degrees, 0 radians plus n times 2 pi. And like I mentioned, n has to be an integer. Now, if you take a look at these three solutions, so this one and this one and this one, and if you were to place all the solutions on a number line, you would have 0, 2 pi over 3, 4 pi over 3, then the next one from here would be 6 pi over 3, and then 8 pi over 3, and then 10 pi over 3, and so on. So you could simplify all of this into just n times 2 pi over 3, where n is an integer. And if you need more details on that, you can refer to your lesson notes from 4.4. So that completes the third example, and now our last one, we've got 3 cosine x plus 2 is equal to 5 secant x, and we want to solve for all x. So the first thing I'm going to do is I'm going to replace the secant x with 1 over cosine x, because of course on the other side we have cosine x, so it would make sense to have a similar sort of thing, so we'll just do a substitution there. And from here, if I multiply both sides of the equation by cosine x, then we'll end up with a quadratic equation that's also trigonometric. So once I put all terms onto one side, set it equal to 0, I can do some factoring. And once I've got it in factored form, as it's mentioned before, either the 3 cosine x plus 5 is equal to 0, or the cosine x minus 1 is equal to 0. For the first factor, you're going to have that the cosine x is equal to negative 5 over 3. Well, of course, cosine can't be negative 5 over 3. Cosine has to be between negative 1 and positive 1. On the other side, cosine x can be equal to 1, and that happens at 0, 2 pi, 4 pi, and so on. So multiples of 2 pi, where those multiples, those n values are integers. So that completes those 4 examples. At this point, it would be a good idea to do some practice on solving equations that involve trig identities. And if you have a question, you are welcome to ask that in class. And hope you found this lesson helpful. Thanks for watching. Bye.